if you are looking at your phone right now, or maybe you're just staring out a window, or, just listening to my voice coming through a speaker,
Right.
the light and the sound that are hitting your senses right now, well, they feel completely instantaneous. I mean, they feel continuous, right?
Well, absolutely. That's the illusion of our daily experience.
Yeah, the illusion. Because what if everything you're experiencing right now is actually bottlenecked by like processing delay?
Which is a pretty massive what if to throw people right out of the gate.
I know, but stick with me here. What if the universe itself literally has a refresh rate? Like, a fundamental hardware limitation that dictates exactly how fast reality can literally render itself.
It's fascinating because it reframes the ultimate speed limit of the cosmos.
Exactly, the speed of light. What if it isn't just some arbitrary traffic rule of the universe, but like the universe's maximum frame rate?
It fundamentally changes how we view the stage we're standing on, really. We usually think of space as just this, this empty void where things happen.
Right, like an empty theater.
Exactly. But looking at it as a substrate, like an actual physical mechanical processor with its own bandwidth limits, that forces us to reconsider the absolute bedrock of modern physics.
And reconsidering that bedrock is exactly what we're doing today. So welcome to this deep dive.
It's going to be a big one.
It really is. And we are framing this entire session specifically for you, the curious listener who really wants to understand the actual fundamental mechanics of reality.
But without getting entirely stonewalled by impenetrable academic jargon, hopefully.
Yes, please. No impossible jargon today. Our mission is to dig into a stack of genuinely revolutionary and honestly highly provocative physics papers.
By an independent researcher named John Sermont.
Right. And we're looking specifically at his work on something called the, let me get this right, the oscillatory dynamics transductive bridging theorem.
Which is quite a mouthful.
Yeah, it's a massive mouthful.
Yeah.
So we're just going to call it ODTBT for short.
It's a much better option.
Much better. And along with ODTBT, we're also going to be unpacking his mechanical derivation of Einstein's E equals mc squared.
I mean, the ambition of those papers really cannot be overstated.
It's wild, right?
It is, because standard physics generally accepts constants known, things like the speed of light or the equivalence of mass and energy, as given axiomatic inputs.
Like they are just the rules of the game.
Right. You observe them, you measure them, you plug them into the equations, and they work beautifully. But Sermont is, he's basically trying to pry up the floorboards of reality to see the wiring underneath.
He wants to see the actual plumbing.
Exactly. He's asking why they work, not just how.
Right, because usually when we talk about fundamental laws, there's this expectation of this absolute rigid architecture.
The bedrock.
Yeah, the physicist points at the speed of light and says, there it is, bedrock. You don't ask why the bedrock is there, you just build the house on top of it.
But Sermont's overarching claim is that standard quantum mechanics and relativity, as incredibly successful as they both are actually missing a deeper mechanical layer of reality.
Which he calls the coherence substrate.
Right. And we want to figure out how this ODTBT theory attempts to explain the why behind the things we just take for granted.
Like why the speed of light is exactly 299,792 kilometers per second. Not a single bit faster, not a bit slower.
And fundamentally what the actual physical nature of mass even is.
Which brings us to, like, the core problem in theoretical physics for the last century, doesn't it?
Oh, absolutely. We have quantum mechanics on one side dealing with the incredibly small...
It's a subatomic stuff.
Right. And then you have general relativity on the other side dealing with gravity and the unimaginably large. And they notoriously refuse to play nicely together.
Yeah, the math just completely breaks down when you try to mash them together.
It does. But Sermont's coherent substrate proposes a shared mechanical foundation, like a unifying geometry that gives birth to both quantum behavior and relativistic speed limits.
Okay, so I definitely want to get into that unifying geometry. But I feel like before we can even talk about the speed of light or Einstein or the giant macro-level universe, we really have to start small.
Very small. We need to go down to the micro level.
Yeah, we have to look at the behavior of the electron.
Starting with the electron is honestly essential, because the macro-level speed limits in Sermont's framework are actually emergent properties.
Emergent, meaning they sort of bubble up from the bottom?
Exactly. They bubble up from what is happening at the absolute smallest scales of this coherent substrate. If you don't understand the jitter of the electron, you simply won't understand the speed of light.
Okay, so let's set the historical stage for you listening. In standard quantum mechanics, there's this famous, and honestly for me, incredibly frustrating idea called wave function collapse.
Everyone's favorite headache.
Oh, totally. If you've ever heard of Schrodinger's cat, you know the vibe.
Right.
In the standard model, which is the Copenhagen interpretation. Right?
Yes, the Copenhagen interpretation.
Right. In that model, an electron doesn't actually have a definite position as it orbits a nucleus. It's just a smear of probabilities.
A mathematical cloud of maybe, as they say.
A cloud of maybe. It exists everywhere and nowhere simultaneously until you, the observer, look at it or measure it.
And then the magic happens.
Right. Then instantly, the wave function collapses and the electron just magically snaps into a specific, definite point in space.
Which is highly unintuitive.
I have to admit, every single time I read about wave function collapse, it feels like a cheat code. It never made any intuitive sense to me that reality requires an observer to exist.
You are in very good company there. Einstein famously hated the Copenhagen interpretation for that exact reason.
Didn't he have a quote about the moon?
He did. He asked his colleagues if they truly believe the moon only exists when they look at it.
Which is such a good point.
It really highlights the problem. The standard interpretation is fundamentally epistemological.
Epistemological, meaning about what we know.
Exactly. It describes what we can mathematically know about the system prior to measurement. But it actively avoids describing what the system physically is when we aren't looking.
It just refuses to answer the physical question.
Right. Which brings us to the very first paper in our stack today.
Yes. So Sermon begins by analyzing the work of another researcher, Vasil Yordanov.
Yordanov created a model called Born-Fokker-Planck stochastic quantum mechanics.
Okay, another mouthful. But what Yordanov did was completely reformulate the famous Bohr model of the atom, and he did something super radical.
He threw wave function collapse out the window entirely.
Just tossed it. Yordanov looked at the movement of the electron not as some magical collapsing cloud of probability, but as an actual real particle with a real continuous trajectory.
He modeled the electron as undergoing stochastic drift, which is more commonly known as Brownian motion.
Okay, let me try to visualize that for everyone. Brownian motion is like, okay, imagine you put a single drop of red food coloring into a glass of perfectly still water.
A classic physics example.
Right. If you zoom all the way in on one tiny red dye particle, it doesn't move in a straight line.
No, it gets bounced around.
Exactly. The invisible water molecules are constantly slamming into it from all directions, so the red particle just jitters. It zigs and zags completely randomly.
It's a stochastic, meaning random drift.
But it is continuously moving through the physical space. It doesn't disappear and reappear like magic.
That captures the mechanics perfectly. In Yordanov's model, the electron is your little red dye particle. It has a definite continuous path, but it is moving incredibly erratically, just drifting through a field.
It's always actually somewhere.
Always. And the breakthrough in Yordanov's math was showing that if you let this random stochastic process run over a period of time, the statistical average of all those millions of random jittery movements,
it adds up.
It does more than add up. It perfectly recreates the exact probability distributions that standard quantum mechanics predicts.
Oh, wow.
Yeah. It organically reproduces the quantum state without ever requiring an observer or a magical collapse.
I want to make sure the contrast here is super clear, so let's build an analogy. The traditional wave collapse model always felt to me like a magician's teleportation trick.
How so?
Well, you have a stage with two boxes, right? The electron is in the left box. The magician drops a smoke bomb, and instantly, like literally zero time elapsed, the electron is in the right box.
Right.
You never see it travel the distance. It just is in the new spot.
And while that is mathematically very convenient for calculating outcomes, that teleportation offers zero mechanical insight into the actual dynamics of the space between the boxes.
Right, it tells you nothing about the journey. So how do we visualize the Yordanov model?
Yeah.
Because it's not teleportation, it's continuous.
Consider a time-lapse photograph of a very erratic insect.
Okay. Like a drunk bee flying around a garden.
Let's use the drunk bee, sure.
Yeah.
If you watch the bee in real time, its path looks like pure chaotic jittering. It darts left, drops down, spirals up. Pure stochastic drift.
Total chaos.
But imagine you leave a camera shutter open for several hours, and you're tracking a glowing light attached to that bee.
Oh, okay.
When you finally look at the developed photograph, that chaotic flight path has layered over itself thousands of times to paint a perfectly symmetrical, beautiful, three-dimensional shape in the air.
Like the shape of a flower blossom.
Exactly like a flower blossom.
Oh, that's brilliant. The bee is always flying continuously. It's never teleporting. But the shape of its flight, the stable quantum state, only actually emerges over time through the statistical averaging of its random drift.
The shape is what we're actually measuring when we talk about the electron's orbital cloud.
Okay, I love that.
Yeah.
But how does this connect to Zermatt?
Well, what makes Zermatt's ODTB framework so compelling is how he interprets Yordanov's mathematical success here.
Because it's not just a math trick to Zermatt, right?
Yeah, no, not at all. Zermatt argues this isn't just a clever mathematical alternative to the Copenhagen interpretation. It's actual physical evidence of field-coherent oscillation.
Field-coherent oscillation. Okay, I read that phrase a dozen times in the prep material, and I really need you to break down what that actually means in plain English.
I will do my best.
What exactly is the field, and why is it oscillating?
We have to look at the math that Yordanov used. In his stochastic equations, Yordanov only needed to use the amplitude of the wave function to calculate the electron's drift trajectory.
The amplitude, that's just the height of the wave, right?
The height or the intensity, yes. But he completely left out the phase of the wave.
What does the phase do?
In physics, phase dictates the timing. It's the sequence of the peaks and troughs as the wave propagates forward.
Wait. If he left out the timing information entirely, how did he still get the right answer for the shape of the electron's orbit?
That exact question is what led Zermatt to his major breakthrough.
Oh, really?
Yes. Zermatt maps Yordanov's math directly onto his ODTBT framework by proposing that the invisible quantum potential that is guiding the electron operates as phase-curved memory.
Phase-curved memory. Okay, I'm going to need you to slow down and unpack that. How can a field have memory, like it remembers things?
Imagine the underlying fabric of space. The substrate itself retains a temporary impression.
Like a footprint.
More like a literal torsion strain. An impression of where the electron just was and where it must move next to maintain the overall stability of the system.
Okay, I'm trying to picture this.
In Zermatt's view, the amplitude of the field dictates where the coherence happens. That's the spatial boundaries of our drunk bee's flight.
The edges of the flower.
Exactly. But the phase, that timing aspect that Yordanov left out of the drift equation, that dictates the timing of the feedback loop.
So the field is pushing back.
Zermatt calls this the transductive cycle. The geometry of the atom isn't just some fixed, rigid scaffold that the electron just sits inside passively.
Right.
The geometry is actively being generated moment by moment by these oscillatory phase constraints.
Okay, I think I'm actually visualizing this now. The electron is the drunk bee jittering around, but the air it's flying through this field is constantly pushing and pulling it based on where it just was a microsecond ago.
It's a constant active feedback loop trying to find stability.
And eventually it builds the stable shape of the atomic orbital.
And the boundary where that stable shape is finally achieved has a very specific designation in Zermatt's work. He calls it the twist boundary.
Twist.
Right.
That stands for threshold waveform interaction for state transformation.
Spot on.
Okay, a state transformation, meaning it goes from being just a random jittering particle to acting as a cohesive, stable part of an atom.
The twist boundary represents the physical threshold between local, continuous movement, which is the bee flying around randomly, and global feedback reorganization.
Which is the completed flower shape.
Exactly. It's the critical juncture where the potential energy of the field organizes into a realized, stable geometric structure.
But here is where my mind hits a massive wall with this.
Okay, lay it on me.
If the electron is actually jittering around continuously and it's communicating with this phase memory field and building this shape over time, well, that has to take time.
Yes.
But standard quantum mechanics treats wave collapse as instantaneous, zero time.
True.
So if Yordanov and Zermatt are right, how long does it actually take for the bee to draw the flower?
Well, the computer simulations that Yordanov ran to test his stochastic model actually provided a specific time frame.
They did?
Yes. He needed to know how many iterations it took for the Brownian motion to statistically average out and perfectly recover the symmetrical shape of the electron's quantum state.
And how long was it?
The math required a duration ranging from femtoseconds to picoseconds.
Okay, a femtosecond is, what, 1/4 of a second?
Correct.
That is incomprehensibly fast. But it's not zero.
And that non-zero duration is the absolute crux of the argument.
Why?
Because a standard physicist looking at Yordanov's simulation would likely just dismiss that femtosecond duration as pure computational overhead.
Oh, like my computer's just thinking.
Exactly. They would say that's just the time it takes the algorithm to crunch the numbers to model a reality that is actually static.
But Zermatt says the computer lag is actually reflecting physical reality.
He does. Zermatt calls this concept temporal holonic memory. He argues this is not a computational artifact at all.
It's real.
He posits that this femtosecond delay is the literal physical time it takes the universe itself to reconstruct coherence across nested field layers.
Okay, this is where the paper really started to melt my brain. You're saying the universe itself has processing lag.
In a manner of speaking, yes.
Like when a video game drops frames because there's too much happening on the screen.
That's a surprisingly good way to think about it. Expanding on Sermont's broader ODTBT picture, reality is composed of a nested, recursively structured, oscillatory field.
Nested, like Russian dolls.
Yes. He refers to these nested structures as holons, which are holes that are simultaneously parts of larger holes.
Okay.
Because the field is strictly mechanical, it takes physical time for information, the phase memory, to propagate up and down these nested layers to complete a transductive cycle.
So the computer wasn't just slow.
Right. The statistical averaging Yordanov's computer needed wasn't a flaw in the code. It was an accurate mirror of the phase-encoded reconstruction of coherence across the universe's own physical cycles.
That just completely flips the script on how we view reality.
It certainly does.
The electron isn't instantly snapping into a probability cloud. It is physically vibrating, drifting into a stable geometric shape, and the universe actually takes a trillionth of a second to process and stabilize that shape.
And we can actually find mathematical evidence of these processing limits embedded right within Yordanov's own paper.
Oh, really? Where?
During his modeling, Yordanov encountered a severe stability issue. When he attempted to model the polar kinetic energy for one specific, highly excited state of the hydrogen atom,
Okay.
known as the 2-1-0 state, the stochastic math completely broke down.
Explain that to me. What is the 2-1-0 state, and how did the math break?
In quantum mechanics, numbers like 2-1-0 describe the specific shape and energy shell of an electron's orbit.
The specific type of flower the bee is drawing.
Exactly. And this particular state has a very complex pinched geometry. When Yordanov ran the stochastic drift simulation for this shape, the variance, meaning the amount the electron was jittering away from the center, started diverging towards infinity.
Diverging to infinity.
The equations just couldn't contain it.
So the drink bee just flew completely off the map. The flower basically exploded.
Yes. And in order to force the simulation to produce the stable shape we know exists in reality, Yordanov had to manually insert a mathematical patch.
A patch. Like a hack.
He introduced a relativistic speed cutoff. He arbitrarily capped how fast the stochastic drift could go.
He just gave it a speed limit.
Right. By enforcing a speed limit on the jitter, the variance stopped diverging, and the model worked beautifully.
So Yordanov just treated it like a software patch. Like, the code is breaking, let's put a hard limit on the speed so the program doesn't crash.
But Sermont evaluates that patch from an entirely different paradigm.
Of course he does.
Sermont states that this cutoff is not an arbitrary computational constraint at all. He identifies it as an emergent twist condition.
Meaning the system actually hit a physical mechanical limit.
Precisely the point. Sermont argues the hydrogen atom in that 2-1-0 state hit its absolute bandwidth limit for maintaining recursive coherence. If the electron drifts any faster than that relativistic cutoff, the underlying field can no longer process the phase information fast enough to pull it back.
The universe's computer can't keep up.
The coherence breaks. So by imposing that speed limit, nature restores phase continuity. It allows the universe's transductive recursion to keep up with the particle.
That is incredible.
It is a literal physical boundary where the system is forced to transition to maintain its structure.
Okay, this gives me chills. So this tiny, jittery electron is bound by the absolute physical limits of how fast the universe can maintain coherence. It's limited by how fast the universe can update its own memory field.
The microscopic sets the rules for the macroscopic.
Which perfectly transitions us into the macro world. Because if the electron is bound by these physical bandwidth limits of the substrate, what does this mean for the ultimate limit in all of physics?
The big one.
Yeah. What does this mean for the speed of light?
That might be the most fundamental question in modern physics, honestly. What actually is c?
Okay, for you listening, c is the variable used for the speed of light in a vacuum. Roughly 300,000 kilometers per second.
Give or take.
Now, in standard physics, specifically Einstein's special relativity, c is treated as an axiomatic input.
Right. It is defined entirely by its observable properties, the invariant ultimate speed of massless particles.
But it doesn't explain why.
No. Special relativity, quite intentionally, offers no mechanical explanation for why it is that exact speed. It does not answer why the limit isn't 400,000 kilometers per second.
Or why it isn't just infinite.
Exactly. It simply accepts that the limit exists and derives the geometry of spacetime from that fact.
It's the bedrock architecture we talked about in the intro. You don't ask what the bedrock is made of, you just build your equations right on top of it.
But reading Zermatt, he refuses to accept that.
He says treating C as an unexplained constant leaves a massive structural gap in our understanding of reality.
He demands a mechanical origin. And Zermatt derives C directly from that deeper, recursive scalar field we were just outlining with the electron.
Okay, how does he do that?
To understand his derivation, we really have to rethink light entirely. In standard classical physics, light is a continuous electromagnetic wave.
Right, a wave.
But in ODTBT, light is not a fundamental continuous wave at the substrate level.
Wait, I need to pause you there. Light isn't a continuous wave.
Not at the deepest level of the coherent substrate, no. Zermatt defines light as a continuous chain of successive discrete events.
Discrete events.
He designates them as SEU sub k events.
SEU sub k scalar emission units. I was poring over this part of the source material trying to visualize it.
The terminology is definitely dense, but the underlying concept is very elegant. Think of an SEU sub k as a localized coherence resolution event.
Okay.
When the underlying scalar field achieves a phase-stable lock at a specific point, it emits an observable event. A chain of these discrete events propagating sequentially through spacetime is what we experience macroscopically as a continuous beam of light.
Okay, I have an analogy for this. Tell me if this works. Think of the universe, this underlying scalar field, as a giant, unimaginably high-definition digital billboard.
Let's explore the billboard. I like it.
When you watch a video of a car driving across a digital billboard, the car isn't actually moving across the physical screen.
No.
No physical object is traveling. What's happening is that individual LEDs, individual stationary pixels, are turning on and off in a very specific sequence.
Yes.
So the SEU sub-K events are those individual pixels firing. And light traveling through the vacuum of space is just a sequence of scalar pixels resolving sequentially in the universe's hardware.
The pixel analogy is remarkably precise for illustrating discrete propagation, and it immediately delivers the mechanical punchline here.
Which is?
The speed of light is simply the maximum refresh rate, or the resolution frequency, of the billboard's hardware.
Wow. The universe's maximum refresh rate. So the reason nothing can travel faster than the speed of light isn't because of some arbitrary traffic law of the cosmos.
No.
It's because the universe physically cannot process the sequential pixels any faster than that. It's a literal hardware limitation of the substrate.
You cannot move a coherent event through the scalar field faster than the field can update its own phase memory.
That makes so much sense.
It's a physical, mechanical limit of the coherent substrate. And Zermatt doesn't just propose this philosophically. He actually provides the mathematical derivation for how this hardware limitation is calculated.
Let's get into the mechanics of that math. How does he actually calculate this universal refresh rate?
Zermatt demonstrates that C emerges from two highly specific properties of the substrate. Mathematically, it equals 1 divided by the square root of the product of two variables,
Okay.
epsilon rec and mu rec.
Epsilon rec and mu rec. Okay, let's unpack these deeply because I really want to understand the physical mechanics here, not just the Greek letters. What is epsilon rec?
Epsilon rec stands for the recursive permittivity of the substrate.
Permittivity.
You can conceptualize it as the substrate's capacitance for phase strain. It dictates how much phase information or deformation the field can accumulate per unit of input before it must resolve.
Let me try to translate that back to our analogy. Epsilon rec is basically how much information the pixel can buffer or hold before it's forced to fire and light up.
Exactly.
It's the delay of writing the memory into the field.
A very effective translation. Now consider the second variable, mu rec. This is the recursive permeability.
Permeability.
It functions as the substrate's inductance. Mechanically, it is the field's resistance to discharging its torsion memory.
Okay, so if epsilon rec is the delay of writing the memory, mu rec is how much the field resists letting go of the memory.
Right.
It's the delay of clearing the pixel so the next one can fire.
The combination of these two phenomena is everything. The speed of light is the geometric mean of the field's susceptibility to phase strain and its physical resistance to memory discharge.
It's just the delay times.
Multiplying them establishes the absolute information delay per unit of spatial propagation.
It literally is the processing time of the universe. Epsilon rec is the time to write, mu rec is the time to clear. The physical stiffness and stickiness of the field dictates exactly how fast a chain of these pixels can propagate forward.
Furthermore, this derivation connects brilliantly to established classical physics.
It does.
Oh, yes.
Oh.
In the 19th century, James Clerk Maxwell formulated the equations for classical electrodynamics. Maxwell figured out that the speed of light equals 1 divided by the square root of the vacuum permittivity, which he called epsilon naught, and vacuum permeability mu naught.
I noticed that when looking at Sermont's Addendum 14, Sermont's equation looks structurally identical to Maxwell's equation for the speed of light.
It is structurally identical.
So why rewrite it with these new recursive labels?
The structural identity is the point, but the ontology, meaning the physical reality of what the equation actually describes, is entirely different. Maxwell's constants, epsilon naught and mu naught, are properties of the electromagnetic vacuum. They describe how electric and magnetic fields behave. But Sermont is arguing that electromagnetic fields are not fundamental.
Oh.
He says these properties originate at a deeper pre-electromagnetic level, the scalar substrate level.
Ah, I see.
The classical vacuum constants that Maxwell measured are merely the macro-level projections of the deeper recursive properties, epsilon rec and mu rec.
He's saying Maxwell was absolutely right about the math, but Maxwell was studying the shadow on the wall, not the object casting the shadow.
Exactly.
Sermont is describing the object, the underlying scalar substrate that generates the electromagnetic effects in the first place.
The shadow analogy fits perfectly here. Light is the fastest thing in the universe because a free propagating photon is just a direct linear chain of these SEU sub K emission events.
The pixels firing in a straight line.
Right. It resolves with zero recursive overhead.
Recursive overhead. Let's dig into that term. The paper mentions this variable called the lock potential, represented by the Greek letter lambda.
To fully understand this, we have to look at the Lagrangian density equation that governs Sermont's recursive scalar field.
A Lagrangian? Remind us what that is.
In physics, a Lagrangian basically summarizes the dynamics of a system by looking at its kinetic energy minus its potential energy.
Okay, got it.
In Sermont's Lagrangian, the final term is this lock potential, lambda. For a free-floating sequence of light, a photon speeding through empty space, that lock potential is exactly zero.
Meaning the light has zero drag, it has no recursive overhead, the pixels just fire and propagate as fast as the hardware allows with absolutely nothing holding them back.
The sequence propagates entirely unhindered by geometric constraints.
But this begs a massive question.
It does.
What happens if the lock potential isn't zero? What if the universe turns on this lambda variable? Because that transitions us right into the third major piece of our deep dive today. If light is a zero drag propagation of coherence, what is matter? What is mass?
Answering that question elevates Sermont's framework from just a novel interpretation of quantum drift into a profoundly unifying theory of everything.
Really?
Because if the lock potential, lambda, is greater than zero, you are no longer describing light. The mathematics dictate that you are now describing mass.
Mass and energy. For over a century, Einstein's E equals mc squared has drilled into our heads that they are equivalent.
They are interchangeable.
Right. A tiny amount of physical matter contains a terrifyingly massive reservoir of energy. We know the math works. We built nuclear weapons and power plants based on it. But I feel like we rarely ask why they are the same thing.
Standard physics treats them as interchangeable via the equation, but conceptually, they still feel like two entirely different categories of existence.
Exactly.
Matter has inertia, it resists movement, it sits there. Energy is dynamic, it propagates, it moves. But Sermont's ODTBT framework dismantles that dichotomy entirely.
How does he dismantle it?
He argues that mass and energy are not two different things. They are two states of the exact same underlying substance. Coherence.
Coherence,
Yeah.
the exact same scalar pixel stuff making up light.
The very same. Sermont defines mass fundamentally as locked coherence. It is coherence that has become trapped in what he calls a zero deviation valley, designated as ZDV naught.
Zero deviation valley. I struggled a bit with the topology here. Let's try to visualize this for everyone.
The most accurate way to picture the ZDV naught is as a basin attractor in a dynamic system.
Okay, for you listening, imagine a large, perfectly smooth ball. If you take a marble and drop it anywhere near the edge of the bowl, gravity will pull it down.
It will roll around, lose momentum.
And eventually settle perfectly at the exact bottom center of the bowl. The bottom of the bowl is the attractor. No matter where the marble starts, it is inevitably drawn to that one stable state.
Now, translate that topological concept down to the coherent substrate. Imagine the underlying scalar field folds or twists in such a way that it forms one of these geometric bowls.
So the field itself bends into a bowl.
Yes, a topological mechanism capable of trapping the transductive cycle. The coherence falls into this ZDV knot basin.
And it gets locked there. It can't propagate continuously like a beam of light anymore. It's stuck circulating in the bottom of the bowl.
It becomes locked, yes. But nature doesn't maintain that lock for free.
What do you mean?
To sustain a stable physical identity for an electron or a proton, to maintain its structure and persist from one second to the next, the universe must continuously spend recursive energy to maintain that geometric lock against the natural phase strain that constantly wants to push the field back to a flat resting state.
Oh, wow. So the universe has to continuously pay an energy tax just to keep the marble locked in the bottom of the bowl, just to keep the atom existing.
The energy tax is everything.
Yeah.
That continuously required energy, when integrated over the volume of the space the lock occupies, physically is rest mass.
Wait, mass is the tax.
Sermont refers to this continuous energy investment as the coherence density, or rho sub c. When you multiply this coherence density by the effective projection volume of the ZDV naught, you calculate the total rest energy of the particle.
This is a massive paradigm shift for me. Mass isn't a hard little physical pellet.
Not at all.
Mass is just coherence density that has been forced into a geometric holding pattern, maintained by the universe's processing system continuously paying an energy tax.
Therefore, mass is locked coherence. Energy, conversely, is released coherence.
So what happens if you break the bowl?
If an external force breaks that lock, if you shatter the geometric bowl, all that stored coherence density is instantly liberated. It expands outward as a continuous chain of SEU sub K events at the maximum resolution rate of the substrate.
It becomes light.
It propagates away as light and heat. That is what energy physically is.
Okay, here's what I have to stop and push back, because this is the specific detail that drove me absolutely crazy when reading the paper.
Let's hear it.
The famous equation isn't E equals mc, it's E equals mc squared.
Ah, yes, E square.
You have mass, you have energy, and the bridge between them is the speed of light squared. Why is it squared? Why not just c? Why not c to the third power? I took college physics, and I swear I have never actually heard a mechanical, physical explanation for why squaring the speed limit is necessary to convert mass to energy.
You haven't heard one because standard model physics doesn't typically offer a mechanical one.
Really?
Truly. In standard physics, the c squared is primarily justified as a dimensional necessity. Look at the units. Energy is measured in joules, which breaks down to kilogram meters squared per second squared.
Okay.
Mass is measured simply in kilograms. Mathematically, to turn a kilogram into a joule, you are required to multiply it by a velocity squared. It's dimensional bookkeeping to ensure both sides of the equal sign balance.
But that's just a math trick. That tells me that it works, but it doesn't tell me why nature chose that specific conversion factor. Why does reality physically demand squaring the speed limit?
That is the brilliance of Sermont's mechanical derivation. ODTBT provides an explicit structural geometric breakdown for why it must be c squared.
Please explain this to me.
Let's review what we established about c. We agreed that c is the resolution rate along a single spatial dimension, correct?
Yes, the speed of the pixels firing in a straight line.
A 1D velocity. Now look at the energy density equation in Sermont's framework. Sermont demonstrates that the energy density within the field involves the mathematical product of two distinct interacting field components.
Two components, what are they?
One component is the phase strain, how much the field is physically stretched or deformed. The second component is the curvature retention, the torsion memory or stickiness we discussed earlier with mrec.
Okay, so the epsilon and the mu are both involved in the energy density.
They are interacting. And here is the mechanical revelation. As the field propagates, each of those two separate components carries exactly one factor of c. So when you calculate the total released energy, which is the product of these two components dynamically interacting with one another, you must multiply the c associated with the phase strain by the c associated with the curvature memory.
You are multiplying a 1D velocity by a 1D velocity.
Exactly. And the result is a 2D geometric footprint.
My mind is officially blown. So c squared isn't just a random large number to balance an equation. C squared is actually a two-dimensional spatial area.
It is the projection area element of this dual component field.
That is insane.
The conversion between the locked state of mass and the released state of energy physically requires c², because energy inherently scales as the product of those two interacting field components.
So the square is real.
The c² is the direct mathematical signature proving that energy is a two-component coherence product, propagating through a substrate whose absolute 1D resolution rate is c.
That is unbelievably satisfying. It makes the math feel so tangible. It also makes so much sense of nuclear reactions. The source text mentions that nuclear fission or fusion, the processes where we split or combine atoms to release energy, are just twist bifurcation events.
That is the formal ODTBT terminology, yes.
Which, based on what we just learned, is basically a highly academic way of saying we are breaking the ZDV knot lock. We are shattering the basin attractor.
You're shattering the bowl.
And when the bowl shatters, all that continuous energy the universe was pumping in to keep the coherence locked in place is suddenly released. The mass unlocks, becomes pure two-component energy, and radiates away at the absolute resolution limit of the universe's hardware.
The difference in the lock potential energy before and after the event is released as unbound SEU sub-K chains.
It's just so elegant.
It's vital to recognize that the substance itself never changed. It was coherence when it was mass, and it is coherence when it is energy. You have only altered the topological geometry of how it is contained.
Reading through the author's notes in this section, I loved seeing where Sermont drew inspiration for this. He explicitly mentions the theoretical physicist Leonard Susskind.
Susskind is one of the fathers of string theory and a master of pedagogical explanations in physics.
Right. Sermont notes that Susskind likes to teach C not just as a speed limit, but as a unit conversion factor between space and time.
Yes.
It's the ratio that tells you exactly how much space equals how much time in our universe.
Which is the foundational principle of Minkowski geometry and special relativity. Space and time are intertwined, and C is the exchange rate.
But Sermont took Suskind's teaching insight a massive step further. Sermont realized that if C is the conversion factor between space and time in the 1D projection geometry, then C² must be the conversion factor between the one-component quantity of mass and the two-component product of energy.
It was a conceptual leap of faith that led to this entire mechanical derivation.
And we must emphasize a crucial point here, right? Sermont's derivation does not contradict Einstein.
Oh, absolutely not. Sermont is not claiming E equals mc² is incorrect. On the contrary, he is mathematically validating it.
He's just explaining the machinery underneath.
He's providing the underlying mechanical plumbing that makes Einstein's observation true in the first place.
He's explaining why the bedrock is solid. He's showing us the chemical composition of the rock.
Precisely.
Or is the bedrock actually solid?
Ah, here we go.
Because this brings us to the final major section of our deep dive. And I have to warn you listening, this is where the theory gets genuinely radical.
It pushes the boundaries, certainly.
If C is just an emergent property, if the speed of light is just the refresh rate dictated by the substrate's permittivity, epsilon, and permeability, what happens if the substrate itself is physically modified?
This specific inquiry leads directly to Proposition 6.1 in Sermont's work, and it is undoubtedly the most controversial element of his entire framework.
Let's lay it out. What does Proposition 6.1 claim?
Proposition 6.1 states that the speed of light c is substrate relative.
Substrate relative. I read that and immediately felt a red flag go up. That really sounds like he is saying the speed of light is not a universal constant.
It demands very careful parsing. Sermont states that c remains perfectly invariant, exactly as special relativity demands, only within a fixed, uniform, coherent state of the local substrate.
Okay, let me challenge this because it really sounds like we are saying Einstein was wrong and that relativity is broken.
Consider the alternative interpretation.
Yeah.
Sermont is very clear. Standard special relativity is absolutely correct, but it only applies to the projected layer.
The macroscopic reality we live in.
Exactly. The reality we measure and observe given a fixed, uniform substrate. If the hardware of our digital billboard is uniformly the exact same everywhere in the visible universe, then the refresh rate is universally the same everywhere.
If the speed limit is dictated by the hardware's epsilon and mu, what if you change the hardware? What if the field itself is actually malleable?
The implication goes even further. If you structurally alter the local substrate, the effective propagation speed of those coherence events, the local speed of light, must mathematically shift.
But how could anything possibly alter the fundamental substrate of the universe? I mean, it's empty space.
Sermont lists several extreme physical configurations where this could theoretically occur. He points to regions subjected to unimaginably strong laser fields or macroscopic systems forced into high recursion depth states.
Okay.
He also suggests that the interior of those ZDV knot shells, the very geometric bowls that hold mass, might have modified substrate conditions. In regions of anomalously high coherence density, the effective epsilon rec and mu rec, the phase capacitance and memory resistance, should theoretically deviate from their standard empty vacuum values.
So if you change the capacitance of the vacuum, you physically change the speed limit of that specific region.
Exactly. The local measuring stick physically changes length.
Zermatt uses an analogy to explain this that really helped it click for me. He compares it to scale invariance.
It is a very powerful analogical tool. How did you interpret his use of it?
He argues that the exact same mathematical mechanism that dictates the speed of light in the vacuum of space is also what dictates the speed of sound in the air.
The dynamics are strikingly similar. The speed of sound propagating through air is entirely determined by the medium's stiffness and its inertial density.
Right.
If you change the density of the air, say, by heating it up significantly or moving to a higher altitude, the speed of sound physically changes.
Right. And he also uses the analogy of a Chladni plate, which I absolutely love.
The great visual.
If you've never seen one, a Chladni plate is a flat metal sheet covered in fine sand. When you run a violin bow along the edge of the plate or vibrate it with a speaker, the sand magically organizes into these incredibly complex, perfectly geometric resonance patterns.
Yes.
The speed that those vibrations travel through the metal plate is the plate's effective C. It's all entirely dependent on the local medium.
Scale invariance means the mechanism of propagation is universal across different layers of reality, but the numerical value of the speed limit is strictly substrate-specific.
So it's relative to the material.
In Zermatt's view, the speed of light is simply the speed of sound for the vacuum of space. If you manage to change the density or the stiffness of the vacuum's coherence geometry in a localized region, you unequivocally change the speed of light in that localized region.
Okay, so we have this proposition 6.1 saying C is substrate relative. It's conceptually beautiful, but as a skeptic, I have to ask, are there any actual real-world observations that support something this wild? Because math on a chalkboard is great, but we need physical data to prove that bedrock can bend.
Zermatt does not shy away from the empirical challenge. He explicitly cites a few experimental implications and anomalous data sets in his paper that suggest this substrate relative behavior might already be observable.
Let's hear them. What kind of anomalies?
The first one he references is an anomaly in deep geological and biological history. It involves the zero-lag covariation between the Earth's geomagnetic dipole and global oxygen levels over the last 540 million years.
Okay, wait, walk me through that. What does oxygen have to do with magnetic fields?
Recent paleomagnetic studies have uncovered a massive, seemingly inexplicable link. Over 500 million years, as the strength of the Earth's magnetic field fluctuates, which is generated by the geodynamo of liquid iron deep in the Earth's core,
Right.
the biological oxygen levels in the atmosphere fluctuate in perfect tandem.
So the core of the Earth and the algae in the ocean are somehow talking to each other.
That is the mystery. The changes happen simultaneously, zero lag.
But hold on, if one thing causes another, there has to be a delay, right?
Yeah.
Even if they are communicating via electromagnetic waves, the signal has to physically travel from the core to the surface, and that propagation is limited by the speed of light, or at least some causal propagation speed.
In standard physics, yes. All causal propagation of information is strictly limited by c. A zero-lag correlation over planetary distances suggests non-local behavior, which deeply troubles standard models.
It breaks the rules.
But Zermatt argues that if c is merely a property of the macroscopic projection geometry, then deep substrate-level correlations don't have to propagate at c.
So how are they linked?
He proposes that the Earth's magnetic field and its biological oxygen cycles might not be causally communicating with each other at all. Instead, they might be two distinct observable macroscopic projections of the exact same underlying planetary scale substrate state.
Oh.
They covary simultaneously because they are tethered together at a topological layer deeper than the speed of light.
They aren't sending signals back and forth. They are just two shadows being cast on the wall by the exact same moving object.
An elegant way to visualize a deep substrate link.
Okay, that's geological data. But the paper also wades into significantly more controversial waters.
It does.
It mentions UAPs, unidentified anomalous phenomena, which is obviously a heavily loaded, stigmatized topic. But I appreciate that Zermatt addresses it purely coldly from a physics standpoint.
He restricts his analysis strictly to the kinematics. He references a specific internal working document that analyzes a corpus of UAP performance data derived from multi-sensor military platform.
Okay.
The data describes kinematics that completely defy standard models. Extreme instantaneous acceleration, hypersonic velocities maintained without generating atmospheric heat signatures, and transmedium travel.
Transmedia meaning?
Moving seamlessly from the vacuum of space into the atmosphere and down into the ocean without suffering any aerodynamic drag or structural destruction.
Things that completely shatter our standard models of aerodynamics, inertia, and mass. I mean, if a physical craft accelerates that fast, the G-forces should turn it to soup. If it moves that fast with the air, friction should just incinerate it.
If you assume the craft is operating within a fixed vacuum substrate, yes, those maneuvers are mathematically and physically impossible. They violently violate the energy-momentum relations of special relativity.
Right.
However, Sermont suggests applying Proposition 6.1. If these objects possess a technology capable of generating a localized envelope that artificially modifies the effective epsilon rec and mu rec of the substrate immediately surrounding them.
Essentially wrapping themselves in an artificial ZDV knot shell.
Exactly. If they can alter the local stiffness of space-time, they aren't breaking relativity at all.
They are just changing the local rules. By altering the phase capacitance and portion memory of this space around the craft, the effective speed of light and therefore all the emergent rules of inertia, mass, and friction become completely different for the craft than they are for the radar operator observing it.
Within the boundary of their locally engineered coherence geometry, the craft is obeying the laws of physics perfectly. It's simply that their localized C, their local substrate refresh rate, is vastly different from our ambient vacuum C.
That frames that entire modern mystery in a completely new, mathematically rigorous light. It takes it out of the realm of magic and puts it firmly into the realm of substrate engineering.
To ground this in observable human science, Sermont also points to current laboratory physics, specifically advanced plasma dynamics. He highlights the Maxwellian versus non-Maxwellian plasma partition.
What is the difference between the two?
In a typical Maxwellian plasma, like the plasma in a neon sign or a basic laboratory arc, the energy distribution of the charged particles is random, thermalized, and chaotic.
Like the Brownian motion stuff.
Exactly. It behaves exactly as standard fluid dynamics and thermodynamics predict. But in highly structured, non-Maxwellian plasmas, specifically things like beam-driven field reverse configurations, which are used in advanced fusion research, the plasma exhibits anomalous structural coupling.
Anomalous structural coupling, meaning it holds itself together better than it should.
It acts entirely too coherent. It resists instabilities that standard fluid dynamics says should definitely tear it apart. Sermont argues these highly organized, non-Maxwellian plasmas are actively establishing a modified local coherence geometry. Because the plasma is so dense and highly structured, it possesses a different effective C within the volume of the plasma itself.
The plasma is modifying its own local substrate just by existing in that super dense state.
This provides a highly testable, laboratory-controlled environment for ODTBT. Sermont suggests that if we develop instruments sensitive enough to measure the propagation of events purely inside these highly coherent plasmas, we should find measurable deviations from the standard vacuum limits of C.
So we've covered massive ground today. Let me try to weave this whole journey back together for everyone.
Please do.
We started down at the absolute smallest conceivable scale, looking at a single, jittery Brownian electron. And we learned that standard quantum mechanics might be completely wrong about wave collapse.
Yes.
The electron isn't magically teleporting, it's drifting, continuously communicating with a phase memory field, and taking a literal trillionth of a second, a processing lag, to build the stable geometry of an atom.
The physical reality of temporal halonic memory.
Right. Then we zoomed out and realized that this tiny femtosecond processing delay is what scales up to become the macro speed of light, the universe's ultimate refresh rate. Sees as just the maximum speed the universe's substrate hardware can update its own digital billboard.
The speed of light is an emergent limitation, not a fundamental axiomatic rule.
Then we pushed further, realizing that mass is just this exact same energy, this exact same substrate coherence, trapped in a geometric bowl, a ZDV, not basin attractor.
And the universe pays an energy tax to keep it locked.
Yes. And energy is what happens when that bowl shatters, releasing the coherence at the speed of light squared, specifically because it's a 2D geometric footprint made of phase, strain, and memory.
Mass and energy are exposed as merely two topological states of the exact same underlying coherent substance.
And finally, we arrived at the most radical paradigm-breaking idea of all. That this universal speed limit, this bedrock constant, might completely depend on the very fabric of the local space you happen to be measuring. If you squeeze the fabric, if you change its density or its capacitance, you change the speed limit. The bedrock isn't solid. It bends.
It is a profoundly elegant, deeply mechanical view of the universe. It doesn't arrogantly throw away a century of verified physics. Instead, it provides the mechanical engine that makes all of that validated physics actually run.
It's incredible. It makes the universe feel less like an empty room and more like a living, breathing processing machine. And it leaves me with one final kind of mind-expanding thought, a provocation, really, to leave you with as we wrap up this deep dive.
I'd love to hear it.
If Proposition 6.1 is right, if the speed of light, and therefore the rules of mass, inertia, and energy, are completely dependent on the specific coherence geometry of the local substrate, could distant regions of the universe have fundamentally different substrates?
That's a huge question.
When we look out through our massive telescopes, like James Webb, at the deepest, oldest parts of the cosmos, we automatically assume that the speed of light and the mass of those distant galaxies behave exactly as they do right here on Earth.
We assume the rules are uniform.
But if the universe's refresh rate varies based on regional substrate conditions, if vast, deep regions of space have a vastly different epsilon rec or mu rec, then our entire view of the deep universe might be distorted.
It's a very real possibility under this framework.
We might just be looking through the localized lens of our own solar system's very specific, very localized vacuum coherent state. The distant galaxies we see might not be moving as fast as we calculate, or they might be composed of completely different masses than our equations tell us. We are blindly assuming the measuring tape is absolute everywhere.
We are assuming the bedrock is perfectly flat, perfectly uniform, all the way to the edge of the observable universe.
Exactly. But if John Sermon is right, the measuring tape itself stretches and compresses depending on where you are. And that means the deep universe we think we understand might just be a localized optical illusion projected by the unique refresh rate of our own little pocket of coherence.
It's a staggering thought to end on.
Thank you so much for joining us on this deep dive into the underlying mechanics of reality. Keep questioning